Hey, this is Mr. Beckstrom again. Today we're going to be looking at Chapter 4.1, Prisms. So let's go ahead and get started here. This section here is on prisms, which are solid figures having at least one pair of parallel surfaces that create a uniform cross-section. And what that means is that we're going to have two opposite surfaces that are going to be the same size, which creates the uniform cross section. Alright, and let's take a look at some specific prisms that we'll be going over today. One of them is a right prism. This is a prism where the bases meet the edges of our lateral surface or our lateral edges at a 90-degree angle. You can see here that if this bottom part is our base, it meets that edge at a 90-degree angle, so that would be considered a right prism. The second figure here would not be considered a right prism because the bases do not meet the lateral edges here at a 90-degree angle. So this one right here would be called an oblique rectangular prism. And then this one right here would be a right prism. It would be actually a right triangular prism, because if you take a look, the top and the bottom, which we can call our bases because they are parallel to each other and the same shape, they meet the lateral edges here at a 90-degree angle. And we have special properties or formulas that we associate with specifically right prisms. So let's take a look at the three formulas we're going to be looking at for these. We're talking about the lateral surface area, the total surface area, and the volume. Let's see what our variables mean. The small p is the perimeter of the base. That's just the distance around the base. The h is our altitude or height. That's the distance between the two parallel bases. And the S, big S, is the surface area, and that's the lateral surface area plus 2 times the area of the base. And then we have the volume, which is the area of the base times the altitude or height. So let's kind of do an example here. Or actually, before we do the example, let's take a look at cubes. So cubes are special right prisms where all the edges meet at right angles and the sides are all the same length. Basically, it is creating a cube where we're going to have 6 identical squares that all meet at right angles, enclosing some type of space. So here the S stands for the length of the side. Let me go back up here to this drawing real quick, and let's look at these pictures and distinguish between what the lateral surface area and the total surface area is. If I'm calling, for example, this right rectangular prism, if I'm calling the top and the bottom the two bases, then all 4 of the sides going around, that's the lateral surface area. And the top and the bottom, which are both the same size, are going to have a specific area for that shape. So that's what we're talking about, the difference between the lateral surface area. Now the total surface area is all 4 of those lateral areas plus the 2 areas from the 2 bases. In this example here, the right prism, our bases are going to have to be the top and the bottom because those are the only 2 sides that are both parallel and the same size. So that's going to be our 2 bases. So the lateral surface area is going to be the 3 rectangles that are produced on the side of this shape here. And the top and the bottom are going to be considered our bases. So we'll have 3 lateral sides, and we'll have 2 bases on this figure right here. Alright, so let's go to our first example here, and let's find the lateral surface area, total surface area, and volume of the following right prism. And this is going to be a little bit tricky because they don't automatically give us all the information that we need. Now first we need to decide what are the bases and what is the lateral sides. So as far as the bases, I need 2 shapes, 2 sides that are parallel to each other and the same size. So we can see through this diagram here that the only two possible, or the only two shapes that we have that are both parallel and equal in size and shape are this triangle here on the front and this triangle here on the back. So those are going to be our two bases. So these three rectangles, they're going to form our lateral area around the prism. Alright, so we're going to need to know a few things before we get started. We're going to need to know the area of the bases, and we're also going to need to know the perimeter of the bases. So looking at this, we have that triangle that's 8 centimeters wide and 3 centimeters tall. And we also know that it's a what? It's an isosceles triangle. And since the line here drops down at a 90-degree angle, we know that this length here is cut in half between 4 centimeters and 4 centimeters. So this should allow us to do a couple of things. It should allow us to find what this side here is, which will give us this side here, and then we can also find the area of the triangle using the formula for the area of the triangle, which is 1/2 base times height. So let's before we go on to the next page, let's talk about what the area would be. So 1/2 of 8 times 3, that's going to be 1/2 of 24, which is 12. So I might jot down on the side that I know the area of my base is 12 centimeters squared. And then the perimeter, I know that this side is 8, so I need to know this side and this side. Well, that's a little bit trickier here, and we're going to have to use the Pythagorean theorem. Because this line meets the base at a 90-degree angle here, and this side is 3, and we know that this side is 4 because we just talked about it, and since it's an isosceles triangle, that center line will divide this length into two equal lengths. So if this is 3 and this is 4, then this hypotenuse of this right triangle here has to be 5 centimeters. It's 3 squared plus 4 squared is equal to c squared. So c squared is equal to 25, and the square root of 25 is 5 centimeters. So that would mean that the perimeter around it is going to be 5 plus 5 plus 8. That's 18 centimeters. Alright, so let's move on to the formula here. First of all, we have the lateral surface area, which is the perimeter of the base times the altitude, or the height. Now remember, going back here, the height is always that distance that's perpendicular to our base. So we see that this distance here meets this base here at a 90-degree angle, so 12 is going to be our altitude or our height. So the lateral surface area is the perimeter times the altitude, which is, we already talked about the perimeter using that Pythagorean theorem, which was 18, times the height, which is 12, which comes out to 216 centimeters squared. Now that we know the lateral surface area, it helps us to find the total surface area. So that's going to be all 5 of those sides of that triangular right prism. So the total surface area is our lateral surface area plus 2 times the area of our base. Well, we already know that the lateral surface area is 216 plus 2 times the area of our base, and we already figured that out. That was 1/2 3 times 8, which came out to 12. So that's going to be 216 plus 24, which gives us 240 centimeters squared. And lastly, we need to find the volume. The volume is the area of the base times our altitude. So we've already figured out both of those variables. The area of the base is 12. The altitude is 12. So the total volume is 144. Alright, so let's move on to the last example here. And we're going to be looking at the lateral surface area, total surface area, and volume of a cube. And you know what I did? I had a cube with 5 centimeters on each side, and I went to the next page and thought I used the one with 4. So let's go ahead and I will correct this before I load this. But let's go ahead and pretend that all these sides are actually 4 centimeters. I apologize for that. So the lateral surface area is just 4 times the length of one side squared. That's 4 times 4 squared, which is equal to 64 centimeters squared. The total surface area is just going to be 6 of those squares. So that's 6 times 4 squared, which comes out to 96 centimeters squared. And the volume is equal to one of the lengths of the sides cubed. So that's 4 cubed, which comes out to 64 centimeters cubed. All right, thank you, and I look forward to meeting some of you in our next instruction. Have a good day.